Hi guys, today is our second day of factoring for finite math. We're going to be talking about sum and difference of two cubes here. I don't think we covered this in Algebra 2, you might have already, but there are two basic formulas for sum or difference of two cubes. First of all, what is a cube? So let's talk about that before I even touch these formulas. The perfect cubes you want to know or recognize, okay, maybe not memorize, but recognize, is 1 cubed, which is 1 times 1 times 1, which is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 is 25, times 5 is 125. Okay. These next two are a little bit bigger, so these are the ones you might not have memorized right away, but 6 times 6 times 6 is 216, and 7 times 7 times 7 is 343. Okay. You can always check these on your graphing calculator or with your calculator, right? 6 to the power of 3, that gives me 216. Okay, or you could do 7 times 7 times 7. Okay. So the reason why we need to know these numbers is when you see them, 1 and 8, 125, 64, 343, and 125, you want to know right away that we can factor using these formulas. And the formulas are, if you have a perfect cube plus a perfect cube, it can always factor into this form. Okay, and notice that a positive factors to a positive, but here it changes to a negative. And here a negative starts with a negative, but then it changes to a positive here. So just be careful of your signs. Okay, so let me show you what I mean. The first thing you need to do is identify what A and B are. Okay, so A equals, for us, this is 1, right? So cube root of 1 is just 1, but there's also an x. So do you notice that this one is 1x times 1x times 1x? Okay. B equals your cube root of 8, which is 2. Okay. So we're going backwards. So if I see an 8, that's what I want. If I see a 1, that's what I want. Okay. So now that I have my A and B established, I'm going to take this formula because we're adding, and we know that it factors into this. Okay. So this is A plus B. So my A value is 1x plus B is 2. Okay. And then here I'm going to have 1x squared. Okay, so let me write this out because right now it doesn't matter, but later it will. Okay. Minus A is 1x, B is 2. Okay. So I'm going to multiply those together, and then plus B is 2, but we're going to square it. So maybe I should color coordinate like what I'm plugging in. Sorry, this squared is part of the formula. Okay. And then I'll do this in red as well because this is what I'm plugging in. Okay. So now we're going to simplify. So 1x times 1x is 1x squared. And then this part, we're going to multiply, and then we do this as well. Okay. So we'll have 1x plus 2. That part never changes. 1 times 1 is 1. And then we'll have x times x is x squared. Minus 1x times 2 is 2x. And then 2 times 2 is 4. And that's it. That's what we've got. Okay. If you multiply this out using distributive or the box method, you will get x cubed plus 8 because things will cancel out in between. Okay. So let's do another one. Oh, I did both of these as pluses. Yeah, let's change it to a negative just for the heck of it. Why not, right? I'll show you how a negative works. It's exactly the same. But notice the cube root is what you're thinking of here, right? Of 125 is 5, and then the cube root of x to the third is x. Cube root of 64 is 4, right? So we're going backwards, and here's the number we have. 64 becomes 4, 125, cube root is 5. And so we're going to just do the same thing, but this time we'll use this formula with the signs being opposite. Okay, so I'm going to have a minus b we will have a squared, which is 5x squared. Notice I have parentheses, because if you didn't have parentheses, then it'd just be 5x squared. But if I put parentheses, this is 5x times 5x, which is 25x squared. Okay. Then we will have, sorry, that's part of the formula, we will have a positive now. These signs are always opposite. And then we're going to have a is 5x, b is 4, and then plus b squared, which is 4 squared. We'll close our parentheses. And that gives us 5x minus 4, and then we'll have 25x squared, right? Because 5x times 5x plus 20x plus 16. And there's no way to factor further. Okay, so if you did multiply 25 times 16 and add to 20, there is no way that those numbers will work out. Okay. Last one. So how I can make this more difficult is to make the exponents larger, right? So if we take the cube root of 343, that's going to be 7. Okay. Cube root of x to the 6 means I want 3 groups of x's, right? So I want 7 times 7 times 7. And then I have to break my 6x's into 3 groups as well. You guys see how that worked out? So it'll be 7x squared. Okay. This one, 125, cube root is 5. And then there are 12 y's that I'm splitting into 3 groups, so divide by 3, which is to the 4th. So 4 plus 4 plus 4. If there are 4 y's, 4 y's, and 4 y's would give me 12y. And so we're going to do the same 2 lines of formula, but now we just have bigger exponents, that's all. A is 7x squared. This is addition, so we're going to continue with addition first. The first term is always a squared. And if it's a sum, then we subtract in the middle of the second parentheses. Okay, then we'll have a times b plus b squared and this gives us 7x squared plus 5y to the 4th. 7 times 7 is 49, x to the 4th, right? X squared times x squared, minus 7 times 5 is 35, x squared, y to the 4th, plus 5 times 5 is 25, y to the 8th. And that's it. Okay, there are 4 problems for you to try here. Pause the video and then I'll post just the answers. I'm not going to show all my work, but I'll post the answers for you to check. Okay, so if you recognize these as perfect squares, that's great. I don't think I would have recognized that 216 is divisible by 27. If you did, though, you would have ended up with 27x cubed plus 8, and then you would do the perfect cube from, the sum of cubes here, which would give you that. Since I didn't recognize that at first, I got this, and then I realized that there's a GCF that I can take out of here, which is 3. And then these 3 terms have a GCF of 9. So 3 times 9, GCF times GCF is 27, and then I have my reduced form here. Okay, and this is important because you always want your smallest numbers, hoping that something can cancel out later. Okay. So let's keep going. Just a reminder that we have learned these 6 methods now of factoring, and I suggest that you always check for a GCF first. Okay, then we try the X method, then difference of squares, grouping, trinomials, and sum of difference of cubes. So you are going to now factor each of these using any method that we have learned so far, because what you want to do is simplify this and factor into simplest form. Okay, so it's not just factor, but you have to factor into simplest form. So what I'll do is I'll pause my video here and I'll show you my step-by-step examples of these, but I would like you to try them yourself if possible. Factoring is one of the most important things that you can have ready in your toolkit for pre-calculus. Okay, here are the 4 answers that I got. I GCF'd first, notice the difference of cubes, GCF'd and then sum of cubes, double GCF, because there was no single GCF that I could use, double GCF, and got a difference of cubes here, which I simplified. This one I took out the y for all of them with a single GCF, and then I tried double GCF, but when I divided, I got 2 different terms in the parentheses. And I've been skipping that step a little bit here. Sorry, do you guys see how like this one I didn't show my work, but I did confirm it's x minus 2 and this one is x minus 2 left over. But since these 2 are not the same, it's not factorable by grouping, which means you need to stop here. Okay, looked like it almost was good because you can see here there's a sum of cubes, but because the 2 parentheses are not the same, you cannot keep going. Hopefully this all makes sense. Try your homework.